Okay, so today's notes are going to be pretty quick. We're just going to kind of expand on what we talked about in class. So we've got two EQs. What is a transversal, and then what are the angle pairs made when a transversal is intersecting two lines, which is the picture that we have right up here. So this is what you got in class. We're going to go through and do the same thing, so some of it you'll already have, and then we're going to talk about the different angle pairs that we have. So the first thing we were going to do is color the interior blue, so I'm just going to use my little highlight tool and color the inside blue right here and right here, and then the outside yellow. So this is yellow. If you don't have this done in your journal, please make sure it's done. Okay, and then we're going to label the interior and the exterior. So inside, in between the two lines, is the interior, and then outside is the exterior. And I'm just going to label both top and bottom so you can see. Okay, so that's what we did in class, and then let's talk about the transversal. So the transversal is this line right here. This line. It is intersecting both lines, so we're going to say it is a line that intersects two coplanar lines. I'm going to write that here in my definition. A line that intersects two coplanar lines. And in this picture, it is line L. Line L. Then we talked about vertical angles. Vertical angles, I'm going to change my color here to purple. Vertical angles are opposite and congruent. So that's what I'm going to put here. Opposite and congruent. So we can list our examples over here on the right. So I could say angle 1 and angle 3. Those would be vertical angles. And then I could say angle 2 and angle 8. And then from the intersection of line H and line L, I could say angle 5 and angle 7. And then I could say angle 6 and angle 4. Then we have some linear pairs that are also in this picture. Linear pairs, for the definition, I'm going to put adjacent. And then I'm also going to put supplementary. So that means they're next to each other, and they sum to equal 180. So I'm just going to put a couple pairs, just two. So I could say angle 1 and maybe angle 8. And then I could also say angle 7 and angle 4. Now these are not the only pairs that are here, but those are just two examples that I would have put on there. So now we're going to fill in the rest of the chart. This is some stuff that we had not talked about in class. So let's talk about these corresponding. So corresponding angles, that's from one set of intersections. So from this intersection, you're going to have corresponding angles to this intersection up here. So that's how we're going to set the angles that are corresponding up. So I'm going to say corresponding angles are in the same location. The same location, which means the same side of the transversal and then the same side of the line. So I'm going to say same side of transversal and then same side of line. So a lot of information there. So for instance, angle 1 would correspond with angle 7. They're both on the left-hand side of the transversal, and they're both above line G and line H respectively. Then I would move over to angle 2. The angle that corresponds to angle 2 is angle 4. They are both on the right of the transversal and above line G and line H respectively. And then I'll move on to 8. Angle 8 would correspond to 6, angle 6. They're in the same location below both lines G and H and on the left of the transversal, which means that angle 3 would correspond to angle 5. They are both to the right of the transversal and below line G and H respectively. Then we're going to move on. We have alternate interior angles. They are on opposite sides of the transversals and then inside the two lines that are being cut. So I'm going to move on and write that right down here. Opposite sides of the transversal. Opposite sides of transversal, and then inside the two lines being cut. So, in our example, the alternate interior angles are going to be angle 8 and 4, and then angle 3 and 7. So they are on the interior, that's how we get interior, and then alternate means they're on the opposite sides of the transversal. So I have 8 and 4, so one's on the left and one's on the right of the transversal. That's what it means by opposite or alternate. Let me take that off our picture. So we're going to move on to the next one, alternate exterior. So again, still opposite sides of the transversal, but now it's going to be on the exterior of the two lines being cut. So opposite sides of transversal. And then now on the exterior of the lines being cut. Okay, the exterior of the two lines being cut. So we're going to have angle 1 and angle 5, and then we're going to have angle 2 and angle 6. So 1 and 5, they're on opposite sides. One's on the left, one's on the right of the transversal, but they're both in the exterior. And then same thing with 2 and 6. There we go, 6. Okay, last one is same side interior. So you can kind of imagine what that's going to be, the same side of the transversal and then inside the two lines cut. So same side of the transversal, inside two lines being cut. And we're going to have angle 8 and angle 7. And then we're going to have, that's a 7, angle 8 and angle 7, and then angle 3 and angle 4. Okay, so we're going to take this information and move on next class and talk about what happens when we cut parallel lines with the transversal, but for now, we just need to know their names and kind of what's going on. So make sure you have this in your journal ready for next class.